All right, let's talk about a classic IT puzzle. What happens when the very security tools that are supposed to protect you end up breaking your most critical apps? You know the feeling, right? It's a dilemma every IT pro dreads. You roll out a powerful new security control, you're feeling great about locking things down. And then the next day, bam, your help desk is just on fire. Tickets are pouring in because some mission-critical application has just stopped. And the stakes here? Well, they are just staggering. The FBI reports that cybercrime losses blew past $16 billion in 2024. That's a 33% jump in just 1 year. We absolutely need powerful defenses, but we can't let them cripple our own business in the process. So to get to the solution, we've got to first define the problem. What are we actually trying to protect? Well, it all starts with understanding your attack surface. Think of your IT environment like a giant fortress. Its attack surface is every single possible way in, every door, every window, even those forgotten service tunnels in the basement. Our job is to board up all those entry points for the bad guys, without accidentally locking our own team out. And this surface is, well, it's huge. It's made up of everything from software that's way overdue for an update, to that server someone spun up for a temporary project and then forgot about, all the way to devices on your network you didn't even know existed. Okay, so this is where our hero swoops in. Microsoft's Attack Surface Reduction Rules, or ASR Rules for short. They are designed specifically to shrink this surface by locking down those exact entry points. And this quote just nails it. ASR rules aren't just looking for old-school viruses, they're like these invisible tripwires that block risky behaviors, the very techniques attackers love to use. And you know what? It works. When you do this right, you can slash the chance of a successful intrusion by over 60%. That's huge. All right, so we've established ASR rules are seriously powerful. But that power can sometimes cause a little, let's call it, collateral damage. So let's look at a very specific real-world example where a great security tool breaks another great business tool. Let's zoom in on this one right here. It's a really common culprit. Its job is to block credential theft from a supercritical Windows process called LSS. It's a fantastic security measure, so of course it's usually turned on by default in most security baselines. But here's the catch. This exact rule can accidentally block completely legitimate enterprise tools. And a perfect example of this in the wild is with a tool called Patch My PC, which is a widely used and trusted solution for automating application patching. So why does this even happen? Well, it all boils down to something called execution context. Think of it like this. The tool starts its job with the master key, right? The all-powerful system context. But then, to do something simple, like check if you have an app open on your desktop, it needs to borrow your key for a second. It has to switch from being the all-powerful admin to just briefly acting on behalf of the user. And this is the really crucial point here. This is a classic false positive. To be super clear, Patch My PC is not doing anything malicious. The ASR rule just sees a process interacting with user stuff, and to be extra safe, it flags it as suspicious. The tool's just doing its job to make sure the update goes smoothly. So what's the fix? How do we make our security hero a little more precise? Well, one thing we absolutely don't do is just turn the rule off. No way. Instead, we use a much, much smarter strategy. The secret is right here. In the different modes that ASR rules can run in, yeah, the end goal is to get to block. But the absolute game changer, the most critical first step, is starting in audit mode. Okay, if you remember one thing from this entire explainer, make it this. Start in audit mode. This lets you see exactly what a rule would have blocked in your environment, giving you priceless intelligence before it causes a single help desk ticket. And this all fits into a really smart 4-step life cycle. It turns what could be a really risky rollout into a controlled, data-driven process. First, you plan which rules you want. Then you test them in audit mode with a small group. From there, you enable them with confidence. And finally, you operationalize, keeping an eye on things long-term. Okay, so once you've got those rules running in audit mode, you get to put on your detective hat. You start gathering intelligence. You can find all these ASR events right in the Microsoft Defender portal. Or if you're right there on the machine, you can pop open the event viewer and look for event ID 1122. That's the one that tells you an audit event happened. So your whole goal here is to hunt for those false positives, those innocent tools like Patch My PC that are getting flagged. The logs give you the exact clues you need, the file paths, to create these tiny surgical exclusions, letting the good stuff through while keeping that shield up to block the actual bad guys. So for this LSS rule we've been talking about, the fix is a path-based exclusion. And you've got options here, right? You can go with a relaxed path, which is super easy to maintain, or you can lock it down tight with a very strict one. Honestly, for most folks, this middle option, the stricter one, it really hits that sweet spot between security and manageability. Look, this process isn't just a one-off fix for a single tool. It's really a blueprint, a strategy for safely rolling out one of the most powerful security features you have in Windows. So I'll leave you with this question. Now that you know the audit-first strategy, what's the first application in your environment you're going to investigate?